Hi and welcome back to Organic Chemistry Module 7, and today we're looking at the properties of amines and amides. So recently we've looked at the nomenclature and how we go about naming these amines and amides, and in our last video we looked at the properties of ketones, aldehydes and our carboxylic acids, and how the various types of bonding that they exhibited in their structure contributed to their physical properties. So today we're going to look at the amines and amides and how their structure contributes to their physical properties. So looking at amines have had a wide range of uses as catalysts and also solvents in the production of dyes, medicines, polymers and so forth. So they're really one of our important groups of compounds. And as we've spoken about in class already, they are also found in nature in our amino acids, in our building of proteins and so forth. So how do we get an amide? An amide actually is formed when an amine reacts with a carboxylic acid, and we do then get our amides. And you can see that similarity in their structure, the similarity between the amine and also the carboxylic acid. And your polyamides are an important group in our synthetic plastics, so we'll look at that a little bit more when we look at our polymers. Urea is another waste product that the body produces, and urea is again another nitrogen compound. So let's look at these properties. Our amines are groups where we're replacing one of the hydrogens there with an alkyl group, and I can see an error there. Let's fix that one up. And because nitrogen is quite electronegative, it's the third most electronegative element after fluorine and oxygen. It's a very polar bond there. So our primary and our secondary amines can form hydrogen bonds due to the presence of that nitrogen-hydrogen bond within the molecule. The tertiaries can't, and the reason they can't is because they are actually not bonding to any hydrogen. So therefore, we would expect our tertiary to have a lower boiling point because of the absence of that hydrogen bonding. But relative to oxygen, the nitrogen is less electronegative than the oxygen. So the hydrogen bonding that we're seeing in amines is lower than that of alcohols, because alcohol has that higher electronegativity between the O and the H than the nitrogen and the hydrogen. So if we were to compare amines to a similar sized alcohol, we would expect the amines boiling point to be lower. So looking at their solubility, our smaller amines, again, are soluble due to the hydrogen bonding that is present there. So you can see the N bonding with the hydrogen. So, of course, we're going to get that hydrogen bonding there. Again, why the smaller one's more soluble? Because as that hydrocarbon chain increases, what's happening again is you're getting greater dispersion forces, and then the hydrocarbon end takes over and outweighs the hydrogen bonding end. Our tertiary amines again are not generally soluble in water due to there being no hydrogen and nitrogen bonds there, so therefore there is none of that hydrogen bonding present. If we look at the amides, as I said before, they're derivative of the carboxylic acids, and what's actually happening is our carboxylic acid, this amine group here, is replacing the OH there. So all our amides contain the CO, meaning the C double bond O, and an NH2 group, and we can have those as primary, secondary, or tertiary. So let's look at some of those properties. So our primary and our secondary amides have two polar bonds. They've got the nitrogen to hydrogen that we've already talked about with their solubility, but they've also got the C double bond O. So our tertiary amides don't have that hydrogen bond because it's attached to three other alkyl groups. So our primary and secondary amides can form the hydrogen bonding, but our tertiary cannot. So that hydrogen bonding again is our really strong bonds, and to break those strong bonds requires a great deal of energy, and therefore that's going to increase the boiling and the melting points of those compounds. And they are tend to be a bit higher than what you would normally expect for the size of that molecule there, again due to that hydrogen bonding. So our small amides, as mentioned before, are soluble in water because the hydrogen bonds are attracted to the hydrogen bonding in the water molecules. And again, our solubility decreases as the hydrocarbon chain increases because that outweighs the other end. So like I've said before, we'll discuss these a little bit further in class, look at the applications of them, take some notes, read your textbook, use those to fill up your notes, and we'll talk in class. See you then.